For Infobright, machine-generated data is everything. So the Internet of Things is kind of right in our wheelhouse. And it's definitely something that we're spending all day, every day, focused on, and it's really exciting. As we look at the types of data we deal with, things like call data records, sensor data, IT logs, web logs, network events, data that is auto-generated and highly structured. What are the requirements of investigative analytics? And by investigative, we mean fundamentally that the query that you're asking is informed primarily by the result of the prior query. You're digging and iterating in order to get to an endpoint. And as it relates to the Internet of Things and machine-generated data, you're parsing through a lot of data to try to understand where are their patterns, where are their issues, and why are there issues. Ad hoc performance is extremely important. It's probably the anchor concept to all of the investigative analytics work. Load speeds we see being more and more an issue. Compression gets more and more important as you're storing very, very large amounts of machine-generated data. The ability to store that in a reasonable footprint has all kinds of implications. It has cost implications. It has retention implications. So if I want to store 30 days versus 7 days worth of data, then all of a sudden I have hardware issues to deal with. And all of these are different cuts at scalability. One of the biggest costs that we've seen is actually the cost of the people associated with maintaining these environments. The idea of investigative analytics is you don't really know what you're going to ask. And if you don't know what you're going to ask, you can't really set up indexes and partitions and do the type of things that you can do in a pre-planned world. The ability to create an environment that's suitable for investigative analytics is one that requires that you figure out a way to do that without having database administrator after database administrator deployed in order to keep the environment performing. And all of this has to be done in an affordable way. Just to say a little bit about what we do, and then I'm going to go to specific use cases. When we absorb the data, we invert the file structure like all of the column stores do, but then we employ a body of work called rough set mathematics applied to granular computing concepts, which I won't really go into here. But fundamentally, the idea is we instantiate this metadata layer that not only contains the physical pointers to the data on disk, but it contains information about the data. And what this generates is an ability to get at the data as if everything were indexed. So it's tantamount to indexing everything, but you're not actually touching the data at all. So there's no database administration required to establish or maintain the environment because of the way we get unbelievably tight compression. So generally anywhere from about 10 to 40 to 1 compression. We get exceptionally high load speeds. We're able to build and maintain this environment in a very, very low touch fashion. And it's not so much big data as it is smart data. Polystar is an OSS supplier in Sweden. They were having scale issues in terms of their queries, and they just weren't able to deliver the type of query response that they needed because the volume that was on the network was growing higher and higher and higher. They were able to increase their query performance dramatically and actually spoke not only to the operational people, but beyond that, customer service, marketing, and other users of the system that wanted to get their hands on this smart data to help them reduce churn, increase upsells, etc. So it goes way beyond just the network monitoring, all the way in through to customer insight, and it's been a fabulous success. One other recent addition that I'll talk about is OPower, a fast-growing company in the smart grid technology space. They wanted to have much faster, much more flexible reporting against a vast amount of data that they were collecting, and it felt that their existing technology for doing that really needed to be better suited for this specific use case. It's been a great illustration of what we think we can deliver for other Internet of Things type applications, and that has been a nice success. Smart grids, smart vehicles, smart cities, mobile health. It's the combination of advanced communication technology and advanced sensor technology. And we think that's a really good indication of the type of data that's going to be put out and consumed and analyzed as the Internet of Things becomes a reality. The combination of a very low-touch environment with high capacity is going to be required for these types of systems. I think with the Internet of Things, the range of problems being solved and the power of solving those problems is just going to be mind-blowing. I mean, there's so many opportunities for doing this once the systems are deployed where you're collecting that data and have the ability to analyze and act on that data.